Okay, in this video, we're going to look at worksheet 13.2. This is Mr. Yo here. If you have not done so, write down your name and your class and your date. Okay, and then I'll begin. So, in this worksheet, we're going to look at some applications of simple inequalities. And before we do that, let's tap on our prior knowledge first. So, in the previous worksheet in 13.1, we covered what the symbols are and what they actually mean. So, let's fill in some examples here. You can fill in your own ones, but I'm going to do mine, and then you can see whether they are the same. So here, for example, 3 is greater than 2, -4 is greater than -5. Okay, and for the less than case, you have 2 is less than 3, and -5 is less than -4. Alright, for the greater than or equal to symbol, well, one possible example is 3 greater than or equals to 3. This definitely works. And -4 is greater than or equals to -5. 3 also happens to be less than or equals to 3. And -5 is now less than or equals to -4. Okay, so let's move on. There is this seesaw example over here. And you should know how a seesaw works. Basically, the heavier side will always be lower, right? So what inequality is depicted by this seesaw? Well, you can say that x plus 3 is less than 7, right? And so if we are being asked to solve the inequality, okay, you can remove this question mark. Solve the inequality, then you are subtracting 3 on both sides. So you should get x is less than 4. Okay, so let's move on to the next page. Here is where we get into more typical exam type questions on inequality. Alright, so let's look at this. Let's try question 1. Solving inequality questions is similar to solving algebraic equations. Let's look at an example. So the length of a rectangle is 3 meters longer than its breadth. Given that the breadth measures x meters, okay, this is important information. Again, length is 3 meters more than the breadth. Breadth is x meters, and the perimeter must be at least 34 meters. So let's write down an inequality involving x. Okay, so we know that x is the breadth, and that means that we can find the length, right? So length now is 3 meters more, so length has to be x plus 3. Alright, this should have been done last term. And then you need to find the perimeter, and that perimeter is at least 34 meters, right? So we need to add all sides of the rectangle to form the inequality, and that's what we get when we take 2 times of x plus 3 and 2 times of x and add them up together. And we know that this has to be at least 34, right? So when we're looking at least 34, well, we're going to have more than or equals to 34, but is 34 more than or is 34 at least 34? Yes, 34 is at least 34. And therefore, you need to include the dash. Oops. You need to include the dash here. Alright, so let me just do that again. Okay, so this is actually your answer for part A. That's it. You do not go on to solve the inequality. Let me just put a note here, and I want you to take that down as well. Do not simplify in part A. Do not simplify or solve in part A. Alright, if you were to do that in an exam, you will not be awarded the marks because it indicates that you do not understand the question. You are only being asked to write down an inequality, not solve it. Alright, you only do the solving in part B. Okay, so the next step, well, just very basic, expanding the brackets. Okay, you should be able to get this on your own. And then how are we going to get to the next line? Well, 4x plus 6, that's simplifying it. Subtract 6 on both sides. So you end up with 4x is greater than or equals to 28. And then you divide by 4 on both sides or multiply by 1/4, and you end up with x is greater than 7. Greater than or equals to 7. So this is only one part of the solution. Right? Because they ask you to solve and find the smallest possible dimensions. Right, so that means that x has to be 7, right? Because you are looking for the smallest possible value of x. So the breadth is 7, and that means that the length is 7 plus 3, 10. Right, so the smallest possible dimension is 7 meters by 10 meters. So you need to give both parts of the answer. Okay. Okay, so you need to answer your questions exactly according to what the question is asking for. Alright, so let's look at this question 2 here. Pizza Palace is running a promotional sale on cinnamon sticks. The hope is to attract more customers into the shop who will also buy a pizza with 2 toppings at the regular price. The Pizza Palace will lose 78 cents on every cinnamon stick order. Profit, however, on each pizza will be $1.32. Okay, so let's take note of this. Breaking even is the worst the pizza is willing to accept. They want the losses from the cinnamon sticks to be less than or equal to the profits from the pizza. So write an inequality expression for this situation. Well, let's break it down into some parts. We won't straight away write down the answer. So let's find the profit from pizza first. And that's quite obvious. You have $1.32 for each pizza, and you have P of them, right? Because let P be the number of pizzas. So this should be 1.32P. In the same manner, you can find the loss from cinnamon sticks. Okay, and now the loss is 78 cents, and you are using C to represent the number of cinnamon sticks, so this should be 0.78C. And recall earlier that we want to break even, so the losses has to be less than or equals to the profits, meaning to say 1.32P has to be more than or equals to 0.78C. Okay, you can leave this as your answer, or you can also do it the other way around. Either answers are accepted and correct. Okay, let's move on to the mastery practice. Go ahead and try question 1 and question 2 first, before you press play to view the solutions. So take note, cross out question B, 1 part B, because it doesn't quite make sense. There isn't enough conditions to write down an inequality, so just do 1 part A and 1 part C. So press pause now, and once you're ready, press play. So now 1 part A, find her earnings for working X hours in terms of X. This shouldn't be too difficult. It is just $15, right? Because $15 per hour, and she works for X hours. So 15x is the answer. What are the possible number of hours she would have worked if she earns less than $75? Well, this means that 15x has to be less than 75. Do I include the dash at the bottom? No, I do not, because 75 is not less than 75. Okay, so 15x less than 75. Solve this by dividing by 15 on both sides. We do not change the sign, so x is less than 5. Right? And well, we have to answer the question. Take note. Okay, the question asks us to find possible number of hours. Okay, and so that means that possible number of hours and it will be good to list them all out: 1, 2, 3, and 4. Right? Okay. Okay, let's look at question 2. The maximum load that a small trolley can carry is 40 kilograms, and the mass of each carton of goods is 5 kilograms. By writing an inequality expression for this situation, find the possible number of cartons the trolley can carry at any one time. So, well, here there is no unknowns given to us, so we need to define them. So let x be the number of cartons. Okay, take note, it is not the number of cartons that the trolley can carry at any one time. Okay, I will not write that down because we're going to construct an inequality. If I were to write down the entire sentence, okay, then I'm only looking for one possible value of x, which is not the correct way to do it. Okay, so in this case, well, well, each one weighs 5 kilograms. So we're looking at 5x, and it has to be less than 40. Do I include the dash now? Well, if the maximum load is 40 kilograms, then I can put 40 kilograms on the small trolley. So I definitely want to have that dash at the bottom. So 5x is less than or equals to 40. Solving for x, I get x is less than or equals to 8 by dividing both sides by 5. And again, remember to answer the question. So therefore, the possible number of cartons will be 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Let's move on to the next page on the extended learning. Alright, this is also actually one of the typical exam questions which you need to learn how to do, and it only comes with practice because there are a lot of different ways of asking this type of question. So listen carefully to the thought processes that I'm going through so that you are clear on how I arrive at the answer. It is not just about getting the answer here. Okay, so let's take note of the inequalities given to us first. A and B are integers. Right? So integers means you're talking about positive, negative whole numbers, including 0 and 0. Alright? And then the next two things, the two inequalities that they have given to us, gives us a lot of restriction as to what A and B can be. So A is between 2 and 5. Inclusive. Okay, take note of that. Okay, so that means to say A can possibly be 2, 3, 4, and 5. And B can possibly be from -7, -6, -5, -4, and to -3. Alright, so these are the possibilities that A and B can take, and these are the only possibilities. We cannot have any fractions, we cannot have any decimals because they must be integers. Okay, so now the greatest possible value of A plus B. Well, how do we arrive at this answer then? If I want to find the greatest possible value of A plus B, then I need to have the greatest possible value of A and of B, right? Because I want to add them both up, so both of them have to be the greatest. Right, so A plus B now, both of them have to be the greatest. That means to say I'm going to choose A to be 5 and I'm going to choose B to be -3. Alright, so just work this out as per normal. 5 plus -3, you get 2. That's your answer. Now, if I want in part B the greatest possible value of A minus B, then I need A to be the greatest and B to be the smallest. Okay, so then that means that I need to pick A to be equals to 5 because that's the greatest, as in the previous question, and B to be -7 because this is now the smallest. Alright, so if I have 5 minus -7, then this will give me negative times negative is positive. 5 plus 7, that is 12. If you're not that convinced that this is the final answer, and this is the correct answer, what you can do is to substitute in some values and try out. So for instance, take 5 minus -3. That gives you 5 plus 3, that is 8, and 8 is, well, smaller than 12. So try it out a few other times and you should be able to convince yourself that 12 is the answer for part B. Okay, now let's look at part C, where it gets a bit more tricky here. The least possible value of A square plus B square. And the property that you need to take note of in this case is that any number when squared becomes positive, right? Okay, so here we are looking for the least possible value of A square plus B square. It means that the numbers, when we square them, they become positive. So for A and B individually, we need them to be as small as possible and as close to 0 as possible. Okay, so let me just take that down here. Need A b to be as close to 0 as possible. Okay, so that when we square them, we get a smaller number, and when we add them, we get the smallest possible. Alright, so here in this case, a square plus b square is going to be equals to, I'm going to select a equals to 2, and I'm going to select b is going to be as close to 0, so I'm going to look at negative 3. So b is going to be negative 3. So 2 square plus, remember to put a bracket around the negative 3 and the square on the outside. Otherwise, you will be making the common careless mistake, and you will be doing minus 3 square, which is going to be wrong. So in this case, this is 4 plus 9. So as mentioned, when you square numbers, you're going to get positive numbers, and when you add them up, 4 plus 9 gives you 13, and this is the smallest possible answer. So I'm done with this worksheet. Go and do the homework, and your teacher will check in with you if you have any questions for the homework, as well as don't forget to complete the reflection component of the worksheet. Okay, so that's all for worksheet 13.2.